Hello, this is Britt Caswell with my next video on factoring. Today we are going to be looking at a process called perfect square trinomials, which I think is one of the most interesting methods of factoring. So the first thing I'm going to show you is I want for you to look for a pattern as I'm writing out these polynomials. Okay, so I have kind of a layout. They have this set up. But I'm going to start filling in numbers, and as I fill them in, I want you to see if you recognize any patterns between those said numbers. So I have a 2 and a 1. I have a 4 and a 4. 6. Just keep thinking here. I'm going to get to this end of this list. Once I'm done writing this, I want you to pause for just a moment and see what patterns you might recognize. The first pattern that many of my students see is they see on this middle section here that it's counting by 2s. So 2, 4, 6, 8, 12, 14, 16, it goes on like that for forever, okay? So this middle section is counting by 2s. It's a very interesting idea. Another pattern that some of my students see is they see this column. In this column, those are our perfect square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9. So now what I want you to do is I want you to take a moment and look between the orange and the yellow and see if you can recognize the pattern that lies between those. So again, look between the orange and the yellow and see what pattern you see that might lie between those. Okay, so you might see that if I divide by 2, I get a 1, and 1 squared is 1. And if I divide by 2, I get 2, and 2 is also 2 squared. Here, if I divide by 2, I get a 3, and 3 squared is 9. And here, if I divide by 2, I get 4, and 4 squared is 16. So they have this number in common. Now here is where it really gets interesting. Okay, so I set up all these parentheses. If you notice, it's a parenthesis being squared. So that squared, remember, means that it's multiplied by itself, okay? And they all have pluses in them. Now understand, in order to get an x squared, I have to have an x times an x. So here at the front, these all start with x. Now here's what tends to blow my students' minds. So these blue numbers are the common number that when I divide by 2, I get when I divide by 2 in the orange column, I get that number. And when I square this number, I get the yellow column. So this pattern that you're seeing here is called the perfect square trinomial pattern. It comes with a couple of formulas, okay? Which I'll be putting on another screen here in just a second. But if you can recognize this pattern, it makes your factoring just so much easier. So now I am starting a new little file so that we can discuss the formula. So the difference of squares factoring has this formula. It says a squared plus 2ab plus b squared is equal to a plus b squared. But you can also have the negative, okay? So, So if in the parentheses you want a minus, you just put a minus out here in the front. However, when you go to FOIL this together, any negative times a negative would create a positive here. So you'll always have a positive in this part. So with that pattern that I showed you on the previous part of this video, you're really able to see just very quickly whether those basic ones can be factored. Now I'm actually going to take this up a notch. I want to deal with values that have a value in front of the x squared. So take this yellow one, for example. 9x squared plus 12x plus 4. So here's what I usually look for when I'm testing to see if something is a perfect square. The first thing I do is I take the middle term and I'm going to divide it by 2. Okay, so 12 divided by 2 is 6. That 6 is called my target number. That's what I'm going to be looking for. Now there is an x there, so I'm just going to put an x in there just so that things line up neatly. The next thing that I do is I actually take the square root of the first term and the square root of the last term. So 9x squared, the square root of that is 3x, and 4, the square root of that is 2. And I'm seeing that if I multiply these two things together, if I get that target number. So 3x times 2 is 6x. So yes, this is a perfect square trinomial. So what we can do is simply take those two things that we squared, plop them in a parenthesis, and whatever this first sign is, in this case it's a plus, is what goes inside the parenthesis. Let's go ahead and let's try another one. So let's try it now with 4x squared minus 20x plus 25. All right, so to start, I'm going to go ahead and find my target number. So 20x divided by 2 is 10x. That's my goal. And then now we take the square root of the first term. That's 2x. And the square root of the second term, and that's 5. So is 2x times 5 equal to 10x? Yes, it is. So we take our parentheses, put both terms in the parentheses squared, and then we take this first sign and we drop it down. Alrighty, one more for the road. So we have 16x squared minus 24x plus 9. So my target number, I have 24x divided by 2 is 12x. That's my goal. So then the next part, right, we take our square roots. So 16x squared, the square root is 4x. Square root of 9 is 3. 4x times 3 does equal 12. So we can say 4x and 3 in the parentheses being squared. And then we take that first sign, the minus, and we put it in between. So some kind of key things to look for so that I know whether I need to do this test is I always look to see if the first term and the last term are on our perfect squares list. Remember, that's on the left-hand side of our factoring big picture. I also look to make sure that this middle term is even. So that's the first thing that I always look for when I'm looking at something if it's factorable, is are there perfect squares on the ends and is the middle one even? Because if so, you have the opportunity to see if you have this pattern. And it's really a wonderful pattern when we are factoring. And that's it. There's my examples. Thanks for watching, y'all. Until next time.